This lesson will work through solving systems of equations by elimination, and then also give a preview of linear inequalities and how we graph them. So let's first of all, our first objective is I can solve systems of equations using elimination. Let's take a look at the steps for doing this. This is another form of solving a system, just like substitution and graphing were. This is going to have its advantages in certain situations, especially when we see x's, y's, and numbers line up. We can use elimination to our advantage. So the steps for us on this are, the first step is to go ahead and get the equations lined up. So what I mean by lined up, you want to have the x's in line, the y's in line, and the numbers. So the x's with the x's, and especially the equal signs. So I'm going to put here x's, y's, equal signs. It's the y squared though, so we'll do x's, y's, equal signs, and then also the numbers all need to be lined up. So when we look at this here, we've already got them lined up. So step one's done for this one. Second is to multiply the entire equation by a factor to get opposites. Either x or y. So if you look at this equation, notice that the y's are already opposites. You want that to happen where they line up and they're opposites. The third step is to then add straight down and solve. And then the last fourth step is to then go back to substitute to get the other variable. Okay, so now we're going to take this first one here, since we've already got it, the first two steps are taken care of. We have the equations lined up with the x's lined up, the y's lined up, the equal signs, and the numbers all lined up. Then we're going to we would want to multiply to get opposites. Well, we already have opposites for the y's. So now we're just going to take these and add straight down. 4x plus 2x gives me 6x. Negative 3y plus 3y gives me no more y's, they're gone. That's why it's called elimination, is because it eliminates one of the variables. Negative 22 plus 16 is equal to negative 6. And so now we can solve this equation. Divide both sides by 6. You get x equal to negative 1. And now we're going to take and use the last step here where we're going to substitute to solve. So pick either equation. I'll pick the second one here. So 2x plus 3y equals 16. Put this negative 1 into that to substitute. So I get negative 2 plus 3y equals 16. Add 2 to both sides. 3y equals 18. Divide by 3, you get y equal to 6. So we got one of them. Now we've got our solution. We've got our x and y. So we get negative 1 comma 6 for our solution. All right, if you want to, you could double check by putting it back into both equations to check. We're going to go to the second example here, follow our steps. So for this one, again, we have the x's lined up, the y's lined up, and the numbers lined up in the equal sign. So these have already been set up so that they're lined up, but that is the first step that you want to do. Now we want to get one of the two variables, either the x's or the y's, to be opposites. Well, I could get these to be opposites, but this looks like a better candidate. Because if you notice with this one, we've already got that if we multiply this one by -2, they will be opposites, so I don't have to multiply both. So I'm going to multiply this by -2. When I multiply by -2, I get -12y, or x, excuse me, plus 10y equals -2 times -8 gives me a positive 16. This one I'm just going to rewrite as is, not change it. And then I'm going to do my adding straight down. I get a total of -4x here. No more y's, the y's are eliminated out, equals 16 plus -24 is -8. Divide both sides by -4, you get x equal to 2. Now we're going to take that and put it into one of the two equations. You get to pick. Okay, I'm going to pick the second one for this one. So I put 8x, I'll put 8 times 2 minus 10y equals -24. 16 minus 10y equals -24. Subtract 16 from both sides, -10y equals, that's going to give me -40. And divide by -10, you get y equal to 4. So my solution, x comma y, is 2 comma 4 for this one. So now we'll do this final example here on these three. So looking at these, again, x's are lined up, the y's are lined up, equal signs, and the numbers are all lined up. Looking to see which one would be best to get to be opposites. Really, it's kind of a toss-up. If I multiplied this by -3, it'd be, excuse me, a +3, it'd be opposite of that y. If I multiplied this one by 2, those would be opposites. So it's really your choice. Both will work. Not a right or wrong answer. I'm going to go ahead and get rid of the x's in this one. So I multiply this by 2 in order to do that. So rewrite the top one. Sometimes you'll have to multiply both equations to get rid of it. Sometimes you have to work through getting both equations into a common multiple. Okay, multiply by 2, you get -4x plus 12y equals -56. And we add straight down. All right, so for this one, I'm going to get for it no more x's. The x's are gone. -18y plus 12y is -6y. And then add these straight down, and I get an answer of, get a 12 for that. So +12. Now divide both sides by -6, you get y equal to -2. So we got our y value. You now have to substitute that back in to get the x value. So I got to pick one of the two. Let's go ahead and pick the first one in this case, just for variety. So 4x minus 18 times -2 equals 68. 4x plus, this will be 36, equals 68. Subtract 36 from both sides. So if I subtract 36 from 68, I should get 32. Divide both sides by 4, you get x equal to 8. And so my answer then is 8 for x and -2 for y. So that gives you a summary of how you can use elimination in ones that are already lined up and that you have to multiply to get to be opposites. Elimination to go ahead and solve a system of equations. Now, the next thing I'd like to do is I'd like to do a little preview for you of linear inequalities in their graphs. These are going to involve shading on the graph and looking at what they how they show up. Later we'll do more than just lines. We'll do parabolas, maybe absolute values. But for right now, I want to just start by a preview with the linear inequalities. So first of all, for this, you have to know that when you're graphing, you're going to have to know whether it's dotted for the line, which will happen, or if you're going to have a solid graph. It's dotted every time you have an inequality that does not have an or equal to on it. So if you have a less than, greater than, those two would be dotted graphs. Whereas solid will be if you have a less than or equal to, or greater than or equal to. Either one of those will give you a solid graph. Next, when you have to shade the graph. So as an example, it would look like this, where you might have a line that's a dotted graph. Okay, now that dotted graph, notice that would be one of these two, and then we would be shading above or below, like for instance, maybe shading below the graph. So it's not just the line, it's all the points below the line, if that's what I was shading. How you figure out where to shade? The first way we're going to talk about it is to test a point. You pick an ordered pair, either above it or below it. You have to decide, test a point and shade if it's true on that side. So for instance, the point that most people will pick a lot of the time, the point that they'll pick will be 0, 0. This is a very common one to pick. And in this case, if we picked 0, 0, it would have worked in the inequality, and so we shade on that side. All right, let's do some examples just so you kind of see what we're talking about here, just as a preview for what we're doing. So if I want to do y is less than 4x minus 2. Now, this is a linear inequality because it doesn't have a square on it. Notice it has a less than, so immediately I know it's going to be a dotted graph as soon as I do it. So when I graph this line, let's start at my y-intercept of -2. So -2 here on my y-axis. I'm going to have a slope of 4, so up 4, 1, 2, 3, 4 over 1. And up 1, 2, 3, 4 over 1. And then draw the dotted line. Okay, there's my dotted line. So you make sure it's very clear that it's dotted and not a solid graph. Now we have to decide, do we shade above it or below it? So what I'm going to do is I'm going to pick 0, 0 here. 0, 0 is a point that's a little bit above it. Now, if you're not quite sure it's above it, it is, but if you're not quite sure it's above it, pick any point that you want to, either above or below, and it should either work or not. Let's test it out. Let's put 0, 0 in. So put in 0 for y. Is 0 less than 4 times 0 minus 2? Is 0 less than -2? And the answer is no, that's false. So we don't want to shade on the side that point is on, 0, 0. So we go to the other side and shade instead. So we're going to shade on this side. Now just to convince you that that's all you have to do for that process. You don't have to pick a point on the other side to see if it works. But let's do that. Let's pick a point on the other side, see if it makes a true statement. So I'm going to pick this point right here. Any point. You could pick a point way over here. If one works, all of them on that side would work. So I'm going to pick this point 6, 0. It should work in this inequality. Let's test it. Put in 0 for y. Is 0 less than 4 times 6 minus 2? Is 0 less than, this would be 24 minus 2, which is 22. And that's a true statement. So notice that that side does work, you pick any other point on that side of the line, it will give you a true statement for the inequality. So the steps again, graph your line, making sure that if it's less than, greater than, make sure you make it dotted. If it's a less than or equal to, greater than or equal to, make it solid. Then test a point. If it works, then every point on that side will work, shade on that side of the line. Let's do another one down here, another example. I've got another graph down here to use. All right, so here's our second example. So our second example is, let's do 3x plus 6y is less than or equal to 18. So first of all, I could graph it in this form if I want to, but let's go ahead and get it in slope-intercept form. So I'm going to subtract 3x from both sides. I'm going to then divide by 6. So negative 3 divided by 6. 18 divided by 6 is just a 3. And then I've got here y is less than or equal to negative 1/2 x plus 3. So there's my simplified version of that. Let's go ahead and graph that. So I'm going to start at 3 on my y-axis, and I'm going to go down 1 over 2. Down 1 over 2. And then I'm going to shade it as a solid line. Okay, because of the or equal to it makes it solid. Now I have to decide, shade above or below. The easiest point typically to test is 0, 0. So let's test it. Let's put it back into the original just because it's easier, and also just to double check that we did our work correctly. So is 3 times 0 plus 6 times 0, is that less than or equal to 18? So 0 plus 0, is that less than or equal to 18? That is a true statement. So we're going to shade, this is going to be on the side of 0, 0. I'm going to shade on this side down here. So that's how you'd shade another linear equality. Now as an extra bonus, what I want to do is complicate it a little bit in the preview. We've been studying systems of equations. What if this were a system of inequalities? What if I had 2 inequalities and I were graphing it? So just as an extra bonus, we're going to do another inequality on this and see what happens when you get more than 1. So I'm going to do 2x minus 8y is less than negative 32. So let's go ahead and get it into slope-intercept form. So I'm going to subtract 2x from both sides. So negative 8y is less than negative 2x minus 32. I'm going to now divide everything by negative 8 and simplify. Now here comes a big point. Notice what's going to happen here. I'm going to flip my inequality over. The reason why is I'm dividing both sides by negative 8. If you recall from your inequalities when you studied them, the thing that will reverse the inequality symbol is either multiplying or dividing by a negative. Here I divided by a positive 6, did not affect the inequality. But when I divide by a negative, that's going to flip it over. So I flip it over to a greater than. Negative 2 divided by negative 8 is a positive 1/4 when I reduce it. Negative 32 divided by negative 8 is a plus 4. So let's go ahead and graph that one. So I'm going to start at 4. I'm going to go up 1 over 4. So out to here. Up 1 over 4. Now, solid or dotted, this one's going to be dotted. This one was solid. This one's going to be dotted because it's not an or equal to. So I'm going to make it a dotted line. Looks like that. And now I want to test to see which side, above the green line or below the green line. Let's test 0, 0, because it's clearly not on the line. If it's on the, If you're not sure it's on the line, then you gotta pick a different point. So let's go back to the original. Is 0 minus 0 less than negative 32? Is 0 less than negative 32? The answer is no, it's not. So don't shade on the side of 0, 0 for this one. Shade on the other side. I'm going to shade above it. So I'm going to shade over here. Now, looking to see where green and purple overlap, it's above this green one and below the purple one. This is the area that I've got for a final graph where these two overlap, is between above this one, below that one. So what we've done so far is we looked at solving systems of linear equations by elimination. We went through those steps and did some examples, and then we're previewing what linear inequalities look like to get an idea of what the visual is for not only graphing a single linear equality, but now we've looked at even a system of linear inequalities and what we can do with them.